Hiya. So the next example, we're going to look at another way of doing change of variables. And this time it's going to be a little bit more complicated. So let's kind of break it down and figure out how to do things. So in this time we're looking at a sphere. So we're going to look at some spheres. So let me draw a sphere to the best of my human abilities. Here's my little sphere. Little sphere. That's not too bad. And we're going to let theta be the latitude. So what I have is, if I have some point here, theta is going to be my latitude. In other words, how high up we are. So this is my theta. If I can draw, this is my theta. And obviously, if you think about this, we're limited as to where we can go, right? Here, the theta is going to be between, up here is pi over 2. This is 0. And here it's minus pi over 2. We'll just do minus pi over 2 rather than trying to figure out, oh, it's 0 to pi over 2 and then 3 pi over 2 to 2 pi. Make our life a little bit easier. And we're going to choose uniformly on this surface. So we can choose anywhere on the sphere. And here we have a unit sphere. So this is another key point, unit sphere. So that this distance here is basically 1. So this distance here is 1. Okay, so we choose some random point on the sphere. Bam. Hard to tell which side it's on, but we'll pretend it's there. And first we want to figure out, well, what's the probability density of theta? Bam. This is already hard to figure out, right? So what we want to do is very similar to how we did the the bacterial colony, I think one, where we had the circle and we'd like put the bacteria randomly on it and we had to figure out the radius. So here, if I have some point here, right, what I'm going to look at is all the points with the same latitude. So here is all the points with the same latitude, so all the things with the same angle. And obviously I need some, so this gives me my function, but I need some height. So first off, what's this function? This function is 2 pi cosine theta. So this function is 2 pi cosine theta, 2 pi cosine of theta. 2 pi being the perimeter, and we just need the radius, right? So this radius here, what's this radius? Well, it's the value of r, the value of x. And so this value of x here, if you think about this, maybe I should have done my circle at the, let me do this, I'm going to undo some of these lines, and we're going to make my circle be where the theta is, because that'll help a little more. Bam. So we'll pretend this red dot is actually our thing here. And so here we'll take this to be our band here. And so what we have is, if I drop this down, right, so I have theta here, which means this bottom part here is cosine of theta. So that's where this radius is, right? So this radius here is cosine of theta because it's the same distance. So we have 2 pi cosine of theta for the perimeter. So perimeter. And then all we need is some height, right? Because this is just a line. It's going to have 0 area. So we need to add a little bit of width. So what we do is we just move this a little by d theta. And that'll give us a tiny bit of width. And now we have an area. So this height is basically d theta. D theta. So we have an area. But remember, what we normally do is we then take a proportion. So what we want is we want to take this band, right? So this is like a little band strip on top. And we want to divide it by this unit sphere area. Sphere area. So what we have is we take this, and we have to divide by the area of the sphere. Now that is 4 pi r cubed, normally. R is equal to 1, so this makes it easy. It's just 4 pi. R is equal to 1. So what we have is pi's cancel. We get 1/2, so we get cosine theta over 2 d theta. And so this gives me the probability density. right? So this is the density formula. Or technically, this part is the density formula. And on top of that, we know the range, right? The range goes from pi or minus pi over 2 to pi over 2. On range, minus pi over 2 to pi over 2. So we basically have that done. So it's not too bad. So in other words, what we have is f theta of theta is equal to cosine of theta over 2. And our range here is minus pi over 2 to theta pi over 2. Nice. Okay, so now we're going to change our variable. So first we have to figure out what the variable is. Next we have to change it. So we're going to let y, in this case, be the vertical component on the sphere between minus 1 and 1. So the vertical component is, if you think about this, I wish I had another color, but the vertical component is here. So in other words, this is going to be our sine, right? So this is sine of theta, if you remember SOHCAHTOA, yeah? So in other words, y is equal to sine of theta. So this is very similar to kind of what we had before. And so plugging these in, the thing is with theta, so let's kind of look at what sine of theta looks like, right? So sine of theta looks like it's this one. So it'll go this way. And here's minus pi over 2, and here's pi over 2. In other words, on our interval, it's increasing. So since it's increasing, we can use our one-to-one method of doing things. So what we do is first we do the range. So here we go from minus pi over 2, pi over 2. Here, since it's increasing, it's one-to-one, we don't have to worry about splitting it. We just go for it. So we get sine of minus pi over 2 to sine of pi over 2. And here you'll notice this is equal to minus 1, 1, right? Which makes sense, between minus 1 and 1. I've already kind of given it to you. Second, we need to take our derivatives. So the derivatives are, so y is equal to sine of theta. So dy is equal to cosine of theta d theta. So dy d theta is equal to cosine of theta. But here, if you kind of remember, yeah, so we have this. Actually, we're just going to stop here for a second. We're going to stop here. So notice how we kind of have this, right? Now, one thing to kind of remember is when we're converting things, we should have that fy of y. This needs to be equal, dy. This needs to be equal to f theta, theta, d theta, right? Everything is kind of equal to one another. They should give you the same things. Over different ranges, but they should be identical formulas themselves. So what we have is, if I look at my f theta d theta, this is just cosine of theta over 2 d theta, which looks very similar to this, except I just need to divide by 2. So in other words, if I divide by 2, I have my fy of y. Fy of y, that was bad writing. Fy of y is equal to 1/2. On the interval minus 1, 1. In other words, we have a uniform distribution. Therefore, uniform distribution. Yeah, so kind of nice in that regards. Alternatively, if you didn't want to do it that way, the way to kind of do it is basically the same way we did, right? So we can do, normally what we do is fy of y. So second approach 1. Approach 2 is the old way. So if you want to do it the second way, approach 2, this, remember, is f theta of theta divided by dy over d theta. So here, df of theta d theta is cosine of theta over 2. So we have cosine of theta over 2. dy d theta, remember, is dy is cosine of d theta, cosine of theta d theta. So dy d theta is just cosine of theta. So we end up getting the same thing. So you get 1/2. So two different ways of doing the same thing. One is using this formula. The other one is using the same formula but in a different way, right? Kind of just by plugging things in, because that's what we saw. Okay, so that's it for this example. We will stop here. In the next video, we'll be talking about cumulative distribution functions, which I think most of you have seen, but it'll be good to kind of go over that. So I will see you then. Bye.